Good day. Today I want to go through how to complete free fall problems. This free fall assignment, what we're going to do is our content objective, discuss how to solve free fall problems. The language objective is I can discuss how free fall problems are similar to and different from kinematics problems that were learned previously. If you haven't already watched the video on kinematics problems or completed that assignment, I would go and do that first because here we'll just be building upon that, adding to that and kind of distinguishing between the two different types of problems. If you open your assignment, what you'll find is that free fall is very, very similar to what we've done with kinematics previously. In fact, if you look at these equations, they are identical to the kinematics equations that we've used. The only difference is sometimes there's delta y that's provided instead of delta x. The main difference between these free fall problems and the kinematics problems is kinematics problems, we are moving left and right horizontally. With free fall problems, you are moving up and down. And so that's why we have the delta y instead. And the main thing we're going to talk about in this video is how do you solve free fall problems specifically and what's different about these sorts of problems. So one thing that's different about these problems is that acceleration is sometimes a given at negative 10 meters per second or negative 9.8 meters per second. Acceleration is just due to gravity on Earth. And so free fall, what is free fall? It's the expression we use for an object that's falling in our Earth's gravitational field with only gravity acting on it. It's freely falling. And so we're not talking objects that have air resistance, friction. There are lots of specifics that you need to read between the lines for with free fall problems. And so that's what we're going to focus here on here. One example about is if you drop an object. So if an object is dropped, what that means is that its initial velocity is 0 meters per second. A problem may not specifically tell you that the velocity is 0, but if you read in between the lines, then you can deduce that information. And so if an object is dropped, it says pushed off a ledge, sitting on a cliff, the initial velocity is 0. Another thing specific to free fall problems, if something returns to its initial position, if a ball is thrown up into the air and then it comes back down, your change in position is 0 because it starts and ends at the same elevation. What you really have to keep track of with free fall problems, more so even than kinematics problems, is positives and negatives. And so anytime something goes down, your delta y would be negative, your acceleration would be negative, your velocity would be negative. Yet another thing is at the peak of something being thrown up in the air, your velocity is positive going up, it's negative when it's coming down. At the highest point, the velocity is 0 meters per second. And so those are just a few things to look out for when you're solving these sorts of problems. The example that we're going to go through, number 8 on this worksheet, what you'll notice is that there's only one number that's given to you in this problem. Again, to solve any kinematics problems, you need 3 pieces of information. And my first step for solving these problems is to figure out the 3 variables that are given to you. And so we're given one number here, and we can deal with this first. So of the different variables that we have, velocity initial, velocity final, acceleration time, delta y, because of the units in meters here, what that means is that our delta y is going to be not 15, but negative 15. An object is dropped from a 15-meter ledge. How fast is it moving just before it hits the ground? And so if something is dropped and it's moving down, our delta y is negative 15. That's all the problem gives us, though. And so we have to look for clues within the problem. First, it says here an object is dropped. And so if an object is dropped, what that means is our velocity initial is going to be 0 meters per second. And it doesn't give us any other information here. So what we have to pick out is, again, something is falling. And so if an object is in free fall, I'm going to use 10. Our object's acceleration is negative 10 meters per second per second. So that's step number 1, identify the 3 variables that we need to solve this problem. Step number 2 is figure out what's being asked of you. And it's asking here, how fast is it moving just before it hits the ground? And so this velocity final is what we're solving for, which means time is not used at all in this particular problem. And the reason that's important, that's sort of step 3 I've gone through for solving problems, is once you know which variable is not used, time is not used, that tells you which equation you're going to use to solve. And so we're going to use the equation VF squared is equal to VI squared plus 2A delta Y. And so VF squared is equal to VI squared plus, and then brackets, 2 times A times delta Y. We are solving for velocity final, so VF squared is equal to VI squared, 0 squared is 0, plus, and then brackets, 2 times negative 10 is our acceleration, times negative 15 is our change in position. So VF squared is equal to, again, these negatives take care of each other, 300. And so VF, if we take the square root of each of these, is equal to plus or minus the square root of 300. Which is it, plus or minus? Since the object is moving down, we should have a negative velocity here. So negative square root of 300 meters per second, and you can type that in the calculator and solve, would be your velocity final, the solution for this problem. So again, this video is all about not how to do kinematics problems, but once you know how to do kinematics problems, how are free fall problems different? What do you need to look out for? If you have any questions, again, please stop on the homework help times, the office hours, and I'd be glad to help. Thank you all very much and have a nice day.